The cosmos beckons, its mysteries stretching endlessly above us, igniting a sense of wonder that has driven humanity for generations. And humanity, ever the explorer, seeks to answer its call. From the earliest stargazers to the engineers and astronauts of today, our curiosity has always pushed us to reach further, to dream bigger, and to build the impossible. Our journey to the stars is a series of determined steps, each building on the last. Every mission, every experiment, and every setback has paved the way for new achievements, forging a path through trial and triumph alike. The story of Starship V3 is a testament to this truth, a machine born of ambition, designed to teach us how to fly, fail, and rise again. Each launch was a lesson, each fiery test a step toward mastery. Its final mission, Flight 11, was not an end, but a transition, the culmination of everything SpaceX had learned through relentless trial and error. It was a moment that honored the countless hours of innovation, risk, and perseverance. Flight 11 soared higher and faster than any predecessor, pushing the vehicle to its limits and testing the hot staging separation one last time. The world watched as boundaries were shattered and new possibilities emerged. The world watched as the Super Heavy booster and Starship upper stage performed with near-perfect precision, a graduation ceremony for a generation of rocketry. It was a celebration of teamwork, vision, and the relentless pursuit of progress. The data gathered was invaluable. Every vibration and temperature spike a lesson for the future. Each reading, each anomaly, became a stepping stone for the next generation of explorers. Starship V3 proved that a fully reusable rocket of this scale was not fantasy, but a solvable engineering challenge. It redefined what was possible, inspiring a new era of innovation and daring. As the V2 era closed, its legacy became the foundation for the next leap, Starship V3. The journey continues, built on the fire, courage, and vision of those who dared to reach for the stars. With V2's lessons absorbed, SpaceX was ready to take its next bold step. The company's relentless drive for innovation meant that every challenge faced with the previous generation became a stepping stone for something even greater. Starbase itself began to transform, mirroring the scale of new ambition. The landscape shifted almost overnight, as construction crews and machines worked around the clock to reshape the future of spaceflight. The old rocket factory was dwarfed by the colossal Giga Bay, a facility designed to build Starship V3 at unprecedented speed and scale. This new complex was not just bigger, but smarter, built to handle the demands of interplanetary travel. Inside, advanced robotics and automated lines work with engineers to streamline the creation of giant steel rings, enabling multiple starships and boosters to be built in parallel. The integration of cutting-edge technology with human expertise created a synergy never before seen in aerospace manufacturing. This industrial might is essential. A city on Mars will require a fleet, not just a rocket. The vision is clear. Mass production is the only way to make humanity multiplanetary. Beyond the factory, launch infrastructure evolved. A second launch pad, Orbital Launch Mount B, joined the original, signaling a dramatic increase in launch frequency. The site was now capable of supporting a tempo never before attempted in spaceflight. Two pads mean one can be refurbished while the other operates, eliminating bottlenecks and enabling rapid, airline-like cadence. This approach brings the dream of routine space travel closer to reality. The upgrades at Starbase are more than steel and concrete. They're a statement of confidence and maturity. Every new structure is a testament to SpaceX's commitment to making Mars accessible. SpaceX is moving beyond R&D, building the factory that will build the fleet for Mars. The focus has shifted from experimentation to execution on a massive scale. The ground is being prepared for humanity's journey to the stars. With every beam raised and every rocket assembled, the dream of interplanetary life comes closer to reality. Starship V3 is a monumental leap, not just an update. A true titan of the skies, taller and more powerful, V3 stretches to 150 meters, its increased volume dedicated to carrying far more propellant. Enlarged tanks hold thousands of extra tons of fuel, the key to escaping Earth's gravity well. New alloys and manufacturing techniques strengthen the hull without excess weight, making V3 both larger and more robust. The upgraded heat shield, informed by V2's lessons, is more durable and easier to produce, crucial rapid reusability. Refined fins offer greater control and stability during descent. Every component has been optimized for performance and reusability. Ship 39, the first of its kind, is designed for Mars, ready to carry habitats, life support, and people. Starship V3 is the vessel that can turn the dream of a Martian colony into reality. A larger rocket demands a more powerful heart. The upgraded Raptor engines. The Super Heavy booster now boasts 39 engines, generating record-breaking thrust and providing redundancy for safety. Even if several engines fail, the flight computer compensates, ensuring mission success and crew safety. The Starship upper stage also gets a power boost, with more vacuum-optimized Raptors for efficient space travel. Advanced sensors and control systems monitor every engine, allowing for preemptive shutdowns to prevent failures. This immense thrust, combined with massive propellant tanks, enables Starship V3 to place unprecedented mass into orbit. This capability is the cornerstone of SpaceX's interplanetary plans. Without this power, sending 100 tons of cargo or people to Mars would remain a dream. The roar of these engines will be the sound of that dream becoming reality. One of Starship V3's most revolutionary features is orbital refueling. Like a car needing petrol stations on a long journey, Starship must refuel in low Earth orbit to reach Mars. The process: a tanker Starship launches, docks with a mission Starship, and transfers thousands of tons of super-chilled propellant. This delicate ballet, never attempted at such scale, is a critical engineering challenge. Orbital refueling means Starship's full payload can be dedicated to cargo or crew, not just fuel. Without it, Mars missions would be limited to tiny payloads. Mastering this technology is the foundation of the Mars plan. V3 is built for this, with docking ports and cryogenic systems ready for the task. The first tests will be milestones, proving the concept and enabling a virtual petrol station in the sky. This is how we build a true highway to Mars. The year 2026 is pivotal, when Starship V3's capabilities are put to the test. The first goal, the inaugural orbital flight of a full V3 stack, validating years of design and upgrades. Next, the first in-orbit propellant transfer test, 2 Starships docking and transferring cryogenic fuel, proving the interplanetary petrol station concept. Another milestone, catching a returning Super Heavy booster with the Mechazilla tower arms, eliminating landing legs and enabling rapid reuse. This maneuver could place the booster directly back on the launch mount, ready for its next flight within hours. The most ambitious goal, launching the first uncrewed cargo mission to Mars, testing the entire mission profile from launch to landing. This Pathfinder mission will deliver scientific instruments and systems, scouting the terrain for future human explorers. Each goal brings us closer to making Mars a reality. Each step, evolving from V2 to V3, expanding Starbase, mastering refueling and catching rockets, is a stone on the path to Mars. Each innovation brings us closer to our goal. This is a systematic process to solve the challenges of becoming a multiplanetary species. Every problem we solve here on Earth prepares us for the unknowns of space. The transition to V3 transforms Starship into a practical, heavy-lift transport system, capable of carrying larger payloads. Its capacity means we can send not just rovers, but the infrastructure for survival, habitats, life support, and fuel plants. These are essential for sustaining human life on Mars. Rapid reusability, enabled by Mechazilla, makes the endeavor economically sustainable. This innovation reduces costs and increases the frequency of missions. The 2026 plan is a dress rehearsal for humanity's greatest adventure. It will test our readiness for the real mission. The first uncrewed Mars landing will prove we can deliver machines, and soon, people, to another world. This milestone will be a giant leap for space exploration. It will shift the conversation from if we can go to when. The success will inspire a new generation of explorers. The work in Texas today is forging the hardware that will turn dreams into history. Every weld, every bolt, brings us closer to Mars. With each flight, the Martian horizon draws closer. We are preparing to leave our cradle. The journey to Mars is not just a dream, it is becoming a reality.